Bismillahirrahmanirrahim. I am Dr.Asad ullah, lecturer, Institute of Numerical Sciences, Cohort, University of Science and Technology. Dear students, welcome to the course of Biomathematics, course code BM-101, lecture number 8. In this lecture, we will discuss quadratic equations and solution of the quadratic equations. In the previous lecture, we discussed the different types of functions and also draw their graphs. In this lecture, we will try to discuss the following points. Number 1, definition and roots of the quadratic equation. We will provide the definition of the quadratic equation and also discuss roots of the quadratic equation. Number 2, conversion of non-standard quadratic equations to the standard form of quadratic equations with examples. Number 3, solution of the quadratic equation. Since quadratic equation can be solved by three different techniques, so in this lecture we will discuss the first technique, that is the completing square method. Number 4, geometrical description of the completing square and roots of the quadratic equation. We will discuss how completing square can be described geometrically and also discuss roots of the quadratic equation geometrically. Number 5, there will be some practice problems to the students, and finally we will provide references. Now, what is quadratic equation? In mathematics, a quadratic equation is a polynomial equation of the second degree. The general form of the quadratic equation is given by equation number 1. Here ax square plus bx plus c is equal to 0, but the coefficient of x square a must not be equal to 0. If a is equal to 0, this equation becomes bx plus c is equal to 0. So bx plus c is equal to 0 is a linear equation. So this equation will be no more quadratic. So in defining quadratic equation, we must know that the coefficient of x square will be not equal to 0. Here b and c are also constant, so b and c are possible to be equal to 0 and x is the variable. These points are also discussed here. If a is equal to 0, a will be a linear quadratic equation, as I have already discussed. Number 2, the coefficient of x square is known as the quadratic coefficient. If a is equal to 0, the quadratic term will be equal to 0 and the equation 1 becomes a linear equation. Roots of the quadratic equation. A real number alpha is called a root of the quadratic equation ax square plus bx plus c is equal to 0 if a alpha square plus b alpha plus c is equal to 0. It means that if we use this alpha in this equation, we get a alpha square plus b alpha plus c is equal to 0. That is, it satisfies the given equation identically. Then we say that this alpha is the root of this quadratic equation. Now, if alpha is the root of the quadratic equation 1, then x is equal to alpha satisfies the equation ax square plus bx plus c is equal to 0. Examples of quadratic equations. In example 1, 3x square plus 4x plus 1 is equal to 0 is the quadratic equation written in the standard form. This equation is quadratic, so we can find the coefficient a, b and c. So comparing this equation with the general form of the quadratic equation, we get a is equal to 3, b is equal to 4 and c is equal to 1. In the second example, where x square minus 3 is equal to 0 is again a quadratic equation. Comparing this equation to the general form of the quadratic equation, we get a is equal to 1, b is equal to 0 and c is equal to minus 3. The variable x is absent here, so that's why we write b is equal to 0. And in the third example, we get bx minus 3 is equal to 0. Comparing this equation to the general form of the quadratic equation, we get a is equal to 0, b is equal to 5 and c is equal to minus 3. Since the quadratic term x square is absent. That's why we write a is equal to 0. So this equation is no more quadratic, and this equation is a linear equation. Non-standard forms of the quadratic equations. So far we have seen the standard form, that is ax square plus bx plus c is equal to 0 of the quadratic equation. But sometimes a quadratic equation doesn't look like that, as shown in the given table. In column number 1, we get x square is equal to 3x minus 1. This equation is not in the standard form. To convert this equation to the standard form, we add minus 3x plus 1 in both sides of this equation. We get x square minus 3x plus 1 is equal to 0. This equation is the standard form of the quadratic equation. Similarly, here 2 times w square minus 2w is equal to 5. To convert this equation to the standard form, first we multiply 2 with w square and then 2 with minus 2w and then add minus 5 in both sides. We get 2w square minus 4w minus 5 is equal to 0. This is the standard form of the given quadratic equation. In this example, z times z minus 1 is equal to 3. To transform this equation to the standard quadratic equation, first we multiply z with z minus 1. We get z square minus z is equal to 3. Now, adding minus 3 in both sides, we get z square minus z minus 3 is equal to 0, which is a standard form of the quadratic equation. In the last example, 5 plus 1 over x minus 1 over x square is equal to 0. To transform this equation to the standard form, we multiply this equation with x square. We get 5x square plus x minus 1 is equal to 0. This equation is the standard form of the quadratic equation. Solution of the quadratic equation by using completing square method. We know that quadratic equation can be solved by 3 different ways: completing square, number 2 factorization, and number 3 the quadratic formula. In this lecture we will discuss the completing square method. The procedure is to apply the completing square method for the quadratic equation is given below. We consider a quadratic equation ax square plus bx minus c is equal to 0, where a is equal to 1. We have chosen the coefficient of x square is equal to 1. So the following 3 important steps are to be required to solve the given equation. In step 1, isolate the terms in x on one side of the quadratic equation. Step 2, add the square of 1/2 of the coefficient of x. That is, add 1 over 2b whole square in both sides of the equation. In step 3, write the square root of both sides of the resulting equation and then solve for x. Geometrical description of the completing square method. To solve problems on the completing square method, first we discuss the geometrical interpretation of the completing square method. For this, consider a quadratic equation x square plus 2x as a square with sides of length x and a rectangle with dimension x times 2. So here this is the square with dimension x and a rectangle with dimension 2 times x. Now cut this rectangle into 2 halves and attach these 2 halves to the square. We get a larger square. This larger square is incomplete because here we get 1, 2 and 3 squares. To complete this larger square, we should add 1 over 2 times of the coefficient of x whole square, that is, in our case, is equal to 1 square. To complete this larger square, just we add 1 square and we get a complete square, that is x plus 1 whole square. Now to understand the completing square method, here we provide the first example, that is x square minus 6x plus 10 is equal to 0. We have to solve this equation by using the completing square method. In solution, First we calculate the term that is to be added in both sides of the equation after separating the variables. That is 1 over 2 times of the coefficient of x whole square. The coefficient of x in this case is minus 6. So we get 1 over 2 times of minus 6 whole square, which is equal to 9. Now separating the variables, we get x square minus 6 is equal to minus 10. Now adding 9 both sides of this equation, we get the result x square minus 6x plus 9 is equal to minus 10 plus 9. After simplification, we get minus 1 is equal to x minus 3 whole square. This right hand side x square minus 6x plus 9 is a complete square. Now taking square root on both sides, we get x is equal to 3 plus minus square root minus 1. Here minus 1 square root is a complex number and it is denoted by iota. So our acquired result will be equal to 3 plus minus iota. These are the two roots of the given quadratic equation which are complex in nature. Here is another example. We have chosen the quadratic function, that is minus x square minus 4x plus 2. To solve the quadratic equations or finding the roots of the quadratic function is the same thing. So here in solution, first we take f of x is equal to 0. F of x is equal to 0 means the given quadratic function reduces to the quadratic equation, that is minus x square minus 4x plus 2 is equal to 0. Isolate the terms in x, we get minus x square minus 4x is equal to minus 2. Now to make the coefficient of x square positive, we multiply this equation by minus 1. That is, multiplying both sides of this equation with minus 1, we get x square plus 4x is equal to 2. Now in step 4, to complete the square, we add 1 over 2 times of the coefficient of x whole square, which is equal to 4 in this case. So adding 4 in both sides, we get 6 is equal to x square plus 4x plus 4. The right hand side is a complete square, so we get x plus 2 whole square is equal to 6. Now taking square root on both sides, we get x plus 2 is equal to plus minus square root 6. Now shifting 2 to the left side, we get x is equal to minus 2 plus minus square root of 6. So we get two roots, that is x is equal to minus 2 plus square root of 6 and minus 2 minus square root of 6. Quadratic equation always has two roots because this is a polynomial of degree 2. So the two zeros are minus 2 plus square root of 6 and minus 2 minus square root of 6. Zeros means the solution of the given quadratic equation. Example number 3. Example number 3 is an interesting and simple quadratic equation. We will solve this equation by using the completing square method. First we write this equation in the standard form, that is x square plus 0x minus 2 is equal to 0. Now separating the variables x, we get x square plus 0x is equal to 2. Now what we will add in both sides of this equation? So 1 over 2 times of the coefficient of x whole square. The coefficient of x in this case is equal to 0, so we get 0 square which is equal to 0. So adding 0 to both sides of this equation, we get 0. So we get x square is equal to 2. Now the left side is a complete square. Now taking a square root on both sides of this equation, we get x is equal to plus minus square root of 2. So we get two roots, x is equal to 2 and x is equal to minus 2. Now example number 4 is also a quadratic function. We will find the roots of this quadratic function by using the completing square method. We use the following steps. First we use y is equal to 0. So we get 2x square minus 1 is equal to 0. Now in step 2, isolate the terms in x, that is shift minus 1 to the left side, we get 2x square minus x is equal to 1. Now to proceed further, here the most important step, that is the coefficient of x square is not equal to 1. In completing square method, we will add the coefficient of x is equal to 1, and then we will add the half of the coefficient of x whole square in both sides of the equation. Now, in step 3, divide this equation by the coefficient of x square, that is 2. So we get 1 over 2 is equal to x square minus 1 over 2x. Now to complete the square, in step 4 we add 1 over 2 times of the coefficient of x whole square in both sides, that is 1 over 16 in this case. So adding 1 over 16 to both sides, we get 1 over 16 plus 8 by 16. The right hand side is a complete square, that is a square plus b square minus 2ab, which is equal to x minus 1 over 4 whole square. After simplification, we get 9 by 16, which is equal to x minus 1 over 4 whole square. Now to find the solution of the given quadratic equation, we take square root on both sides, which gives x minus 1 over 4 is equal to plus minus square the root of 9 by 16. Now shifting minus 1 over 4 to the left side and taking the square root, we get 1 over 4 plus minus 3 by 4 is equal to x. First we add these two terms, we get 1. And after subtracting, we get minus 1 over 2. So the two roots of the given quadratic equations are minus 1 over 2 and 1. Now to geometrically understand what roots are and how to find roots from the graphs of the quadratic equation or any polynomial equations, here we consider two different functions that are already discussed in the previous slides. Y is equal to x square minus 2 and y is equal to x square minus 6x plus 10. First, I discussed the graph of y is equal to x square minus 2. That is the form of parabola. This graph crosses the x-axis, that is larger than the point 1 and less than the point minus 1. In the previous slides, the roots of this quadratic equation are square root of 2 and minus square root of 2. So this point is square root of 2 and this point is minus square root of 2. So those points at which the parabola crosses the x-axis are the roots of the given quadratic equation or the quadratic function. While in the right hand sides, this is the graph of x square minus x plus 10. This graph is also a parabola, but it is not crossing the x-axis. So what will be the roots of this equation in this case? This is the parabola in the plane. So we discussed the solution of this equation in the previous slides, which are in the form of complex roots. So it does not crosses the x-axis, so the root lies in the plane and we get the complex roots. Practice problems to the students. Here I am presenting some problems to the students, and students are requested to solve these problems. If you have any issue in these problems, you can contact me on my email address given at the footnote of this slide. Here are some more interesting examples, that is problems 15 to 27a. All these problems are quadratic and students are advised to solve these problems by using the completing square method as we discussed in this lecture. Finally, in the references, all the materials in this lecture are provided from the given references. Students are requested to focus on the reference 1 and reference 2.